Tep Talks education. Let us continue with detection of ions in solution. And since we are already done with the detection of cations in solution, let us move to the detection of anions. Let's go to the detection of anions. So, I want us to be able to remember the anions that we talk about at this level clearly. These anions are the sulfate ion, we have got the chloride ion, we have got the carbonate ion, and we have the nitrate ion. Mainly these four major anions that we deal with at this level here. So we are going to see how we can detect them in solution, these anions here. And also for some of them we shall also try to see how we can detect them when they're in the solid state. That one will come later on, but let us first try to see how we can detect them in the solution or when they're in this aqueous state. So let us start with the first one, that is the sulfate ion. Detection of sulfate ion, which is SO4 2 minus. So we have got some reagents that we use for detecting the sulfate ion. So let me draw a table here. We first look at the examination format in this case, how they bring it in exams. So we shall look at the tests and then we shall look at the observations as well as the deductions. So let us start with the tests. We also look at the observation that we shall make as a result of the test, and then what we can deduce from that in terms of the ionic composition. So, testing for sulfate ion, one of the reagents that we can use in this case is the lead to nitrate solution. So, we can be told to add a few drops of lead to nitrate solution. Just this only, that you add a few drops of lead to nitrate solution. Sometimes they specify the number of drops. They can say add 3 drops, add 4 drops, add 2 drops, or they give you a range. Add 2 to 3 drops, add 4 to 5 drops, add 3 to 4 drops of lead to nitrate solution. When you do this, you are going to get a white precipitate. And this one is indicate that there is sulfate ion. Now let us see the chemistry here. Here, the lead to nitrate solution contains lead to ion and then the nitrate ion. So the lead to ion of the lead to nitrate solution will combine with the sulfate ion in the solution under test, and then we get a solution, or we shall get a precipitate of lead to sulfate. So the lead to ion, which is in the solution of lead to nitrate, will combine with the sulfate ion in the solution under test, and we are able to get, in this case, the insoluble lead to sulfate, which will be precipitated. So let me bracket it here, or let me use another ink color or another marker color, so that you know that the bracket is not part of the equation. So that is the equation for the reaction which is involved in this case. So when you see it saying that you add a few drops of lead to nitrate solution, then you are able to get a white precipitate if you do that, and then your deduction will be sulfate ion. In this case, we are still dealing with the sulfate ion only. 2, you can also be asked to add a few drops of lead to nitrate solution, and you heat. Remember, we are dealing with a solution suspected to be containing sulfate ion. And now, if you have carried out this test, if there is sulfate ion, you are going to get a white precipitate. We shall get a white precipitate. Remember that the white precipitate which is formed here is lead to sulfate. This test is the same as this one here, only that we have added the element of heating in this case. So at first we get a white precipitate that will be lead to sulfate. Then when you heat, the precipitate will fail to dissolve. That means it is insoluble on heating. The equation for the reaction remains the same, that the lead to ion in the solution under test, this lead to ion will combine with the sulfate ion, and we shall have the precipitation of lead to sulfate. I want us to be able to remember this, that heat has got no effect on the solubility of the lead to sulfate which has been formed. That's why you can see that when we get the white precipitate, it will be insoluble on heating. That means that even if you heat it, it will not dissolve. So if you have got this observation, it means that you have in the solution sulfate ion. So here there is sulfate ion, and that is what we can deduce from this observation here, and that one is for sulfate ion. Another test that we can perform in this case is that I can specify the number of drops here. Let me say, if we are to add 4 drops, remember that we are always using 1 cubic centimeter of the solution of the substance under test. We normally use just 1 cubic centimeter. So we can add 4 drops of barium nitrate solution, followed by the same number of drops of dilute nitric acid. Add 4 drops of barium nitrate solution followed by 4 drops of dilute nitric acid. As well, we can have this test here still carried out in a different way altogether. Let me use dots here to show that these are the same reagents, only that the order of the addition of the reagents may vary a little, as we can see from here. We can also say add 4 drops of dilute nitric acid followed by 4 drops of barium nitrate solution. So we can see that we are using the same reagents here. That is barium nitrate solution, and we are using dilute nitric acid. I want us to know that in this case, the barium nitrate solution contains barium ion, which combines with the sulfate ion in the solution under test and form insoluble barium nitrate, which will be formed as a white precipitate. So in this case, when we add barium nitrate solution, we expect to get a white precipitate. But then see, we have got dilute nitric acid here. The dilute nitric acid has got a specific purpose here, in that you see the solution may not be containing exactly sulfate ion. It may be containing carbonate ion, or it might be containing sulfite ion. So if the solution contains carbonate ion or sulfite ion, should you add barium nitrate solution to it, then we are going to have a reaction whereby the barium ion will combine with the carbonate ion in the solution, which you thought is a solution containing sulfate ion, and we get still a white precipitate of barium carbonate. And this one also would combine with the barium ion in the barium nitrate solution, and it gives us a white precipitate still of barium sulfite. So we get in this case misled by thinking that the solution contains what? Sulfate ion, yet it might be containing carbonate ion or sulfite ion. So to avoid this, or to avoid being misled, we also use dilute nitric acid. So the dilute nitric acid will be able to break down any carbonate ion or any sulfite ion that may be present in the solution under test. That will make us think that the solution has formed a white precipitate of barium sulfate, yet is barium carbonate or barium sulfite. So we fail to detect the sulfate ion correctly, because carbonate ion or sulfite ion in the solution will have interfered with our test by also forming a white precipitate of barium carbonate or barium sulfite respectively with this one here, with the barium nitrate solution. So we don't have to forget this, and for that reason what we need to do is to add dilute nitric acid, and the dilute nitric acid will be able to destroy the carbonate ion, or the sulfite ion, which may be present in this case as an impurity. So we don't have to forget that. In this case, we don't have to forget this. So if this one has already been destroyed by that dilute nitric acid, then it means that here we are going to get correctly we shall get correctly our white precipitate. Let me use black. We shall get a white precipitate, and since the white precipitate is not barium carbonate, it is not barium sulfite, then that means that even if we add dilute nitric acid, which we say that it is meant to destroy any carbonate ion or any sulfite ion that may be present as an impurity, our white precipitate will persist, it will not dissolve. So we get a white precipitate insoluble in the acid, and this one is a significance. This one signifies rather the presence of sulfate ion. So take note that the acid simply destroys any carbonate ion or any sulfite ion which may be present. In this case, I can call it an impurity, which would otherwise form also a white precipitate with the barium nitrate solution. So for us, we may think that there is sulfate ion yet there is carbonate ion or there is a sulfite ion. But if we have added the acid and then the white precipitate fails to dissolve, it is insoluble in the acid, then we know that the solution contains sulfate ion, and this white precipitate is actually our barium sulfate solution which has been present, which has been formed, and therefore there is sulfate ion. If we use dilute nitric acid first and then the barium nitrate solution follows, then the acid will have first to prepare the way for the action between barium nitrate solution and then the sulfate ion which might be present. So the dilute nitric acid will destroy any carbonate ion or any sulfite ion first. Then when we add the barium nitrate solution, should you get a white precipitate, then that one is exactly barium sulfate which has been formed. So here, if there is sulfate ion, we get a white precipitate because the acid will have already cleared the way. It will have already destroyed any carbonate ion or any sulfite ion that may be present. So let us generally look at the equation for the reaction in this case. Our reaction equation is the barium ion combines with the sulfate ion in the solution under test. So the acid is just only for clearing the way and showing us that it is not carbonate ion, it is not sulfite ion, it is what? Sulfate ion which is present. So in this case, the barium ion of the barium nitrate solution combines with the sulfate ion in the solution under test, and we get barium sulfate which will be precipitated, and still this one signifies the presence of, it signifies the presence